As we've been reporting in SD Times, AI agents are powerful tools that organizations can use for all sorts of purposes, gaining observability into running applications, data analysis, autonomous decision-making, and much more. Each agent can be remarkably effective in completing its tasks, but they lack full knowledge of the domain they're in. This creates a need for deploying multiple agents that can work in parallel to handle larger workloads or process information more quickly, but orchestrating these agents is imperative. So here to talk about the challenges of and solutions for agent-to-agent collaboration are two of the folks from a company called Solo.io, which is involved in creating a platform for agentic integration. Joining us are Michael Levan, he's a principal engineer, and Sebastian Magnac, he's a principal solutions architect at Solo. So Sebastian, let's get started.
Awesome. Yeah, thanks for having us, man. We are really excited kind of to dive into Agent Gateway and talk about agents and A2A kind of stuff. And just to kind of presence, Agent Gateway is an open source project by Solo.io and backed by the Linux Foundation. It's the secure middleware for the agent economy, right? So it allows us to help connect, secure, observe communication between agents, between AI agents, between tools and LLMs, no matter which framework you use, if it's LangChain, Crawl AI, AutoGen, etc., right? It doesn't really matter. And it's built on two open protocols, A2A that we're going to talk about, and MCP today, Model Context Protocol, which is kind of what everybody's calling the USB hub of agents or AI itself. And the way to think of it as Istio for AI agents, right? We have authentication, we have MTLS, mutual TLS, we provide rate limiting, observability, unified UI dashboard, all framework really agentic. And we believe that the future of the multi-agent system is interoperable, right? And I think Agent Gateway is making things happen today, and we are seeing this through our conversations with our customers, with our partners itself. And I know Michael's got some cool stuff we're going to dive into. So I'll give it to you to kind of dive into the demo that we want to kind of showcase today.
Awesome. Thank you so much. Really appreciate it. And hello, everybody. Good morning, good evening, good afternoon, wherever you may be in the world. Sebastian and I are on the East Coast, so we're just wrapping up lunch here at 1 o'clock. So one of the things that I kind of wanted to dive into first and foremost was really to talk about what A2A is, right? The agent-to-agent protocol. And by the way, before we jump into the demo, I do just want to say I have the chat window up on the right-hand side here. So if you have any questions as I'm going through this, definitely feel free to pop them in. Like, you don't have to wait till the end or anything like that. We can make things as interactive as possible. So feel free to put those questions in, and I'll stop where it's an appropriate time and dive on in.
I'll dive into those if you're in the middle of something, so which is great.
Perfect. Thank you. Appreciate it. I'm just moving some screens here so I can start to share. All right. I'm going to share the entire screen because it makes life easier. Okay, cool. So everybody should be able to see that.
Yeah, that's great.
Perfect. All right. So the first thing that I wanted to do was I woke up this morning and I went to the gym, as I always do. And then I said, you know what? How can I make this a little bit more fun to kick things off, right? So let's skip the slides and all that stuff, and let's actually dive into getting some information. So I said, all right, instead of just thinking about or talking about A2A from a theoretical standpoint, let's ask an agent what it thinks. So I built this like little mini agent, only a couple lines of code here. I'm using Ollama, I'm using Ollama locally, but I'm using the DeepSeek model. So you can see that if I can, you can see Ollama's running here locally. Temperature is set super, super low. That way we can get some good, accurate answers. And then I'm just hitting this locally. And I have a little bit of a RAG implementation here, essentially just going out to the latest docs for A2A. And then I'm going to ask it a simple question, right? Like, what is A2A? All right, so I'm going to kick this off. I'm going to give this a couple of seconds.
We're using AI to answer.
That's it. Yeah.
AI, man.
Let's see what it gives us. I was also thinking about not putting like the RAG implementation in here because this is pretty cool. If nobody's ever heard of this, it's essentially like a Google search for AI. Excuse me, sorry. So we can see here, Crew AI is going through, it's executing the task, right? Here's the thought, here's the tool that it's using, and here's the final answer. So I'm going to go ahead, I'm going to read that. The agent-to-agent A2A protocol is an open protocol that enables communication and collaboration between AI agents, regardless of their origin or framework. It provides a standardized interface for agents to exchange information, coordinate actions, and collaborate securely. What do you think, Sebastian? Is that pretty accurate?
I think it's pretty good, right?
Not bad, not bad.
Not bad.
Yeah. So I think that's really what A2A comes down to right now. And I'll take a step back and I'll say this. Maybe this protocol is going to change. Maybe it might not be the protocol in 6 months or a year. And who knows, right? Because I think that we're in a very interesting time with technology where like things are moving way faster than they did before. And I know like everybody always says that, right? You know, this new thing came out, it's moving faster than ever. But really, if you think about it, right, like when we went from bare metal to virtualization, when we went from virtualization to the cloud, went from, you know, cloud to Kubernetes, we had like a couple of years in there each transition period where like we had time to vet things out. We had time to test things. We had time to make sure, hey, this is the thing that we should be doing. With AI and everything agentic, we haven't really had that couple of years to test things out. Like a good example is MCP. So like MCP, the Model Context Protocol, is the standard right now, but it hasn't even been out a year yet. I think on the 25th of this month, it's out for a year.
Mm-hmm.
So it's just kind of like something to think about. And I bring that up because as we're going through this and as we're talking about these things and as we're doing these demos, I want you to know that these are the standards right now. These are the protocols right now. But of course, you want to make sure that you're keeping yourself up to date because things are moving very rapidly. So
it's pretty wild with the whole MCP adoption. Like I feel, I forgot what the last number, but there was I think 17 or like 12,000 publicly MCP servers already existing in less than a year, and it's just wild.
Yeah, 100%. Yeah. And I think like I want to say the velocity, like last time I read was, and it makes sense based on the number you're saying, it's like 1,000 MCP servers a month, give or take. So that's pretty insane. Apologies if I mute myself here a couple of times. I've had a cough for about a month now and I just can't kick it. So, all right. The first thing that we're going to dive into is creating an actual agent. Okay, so what does that look like? And what tools can you use to make this a little bit easier? Okay, so the first thing is, what framework do we want to use? So with this little experiment on the A2A definition that I did before, I'm using Crew AI, right? One of the frameworks. Now, another framework that you'll hear about a lot is like, you know, LangGraph, for example. And the way that I explain these is Crew AI is for it. I would say it's my opinion, but I also know that a lot of people are feeling the same way. So Crew AI is more for like some basic tasks, right? Like this was a basic task that I put together, right? And when I say task, I'm talking about like the agent's job as a whole. LangGraph is more like, I would say, advanced level agents. You know, like just as an example, you work in a financial institution and you want to create an agent to, you know, go read analytics for day-to-day day trading, right? And like kind of seeing the market and seeing where things are going and maybe making some assumptions based on, you know, what's going to happen in the future, right? So maybe you're going to use a framework like LangChain that's a little bit more advanced for stuff like that. Now, what I like about ADK, which you can see here, the Agent Development Kit, is it's kind of sitting like in the middle in a sense. So like it's great for complex tasks, and it's also great for just, hey, I want a quick agent to do a quick thing. All right. So that's why I decided to go with ADK. Now, this agent, it's pretty straightforward. It's using Anthropic, so I'm using the Claude 3.7 model. And essentially what I'm saying here is, you know, answer all questions about like Kubernetes and Istio, right? Like you are the experts of Kubernetes and Istio. Now, another piece of the puzzle here that I'm implementing is the MCP toolset. So like Sebastian mentioned before, and like I was talking about a little bit, MCP, Model Context Protocol servers are the standard right now. And underneath the hood, if you take a look at what they are, they're usually Python packages or JS packages. If you're using standard input-output SCDIO, that's like a PyPy package or an NPM package you're running locally, where it's not actually installed locally, it's more running in like a cache. Streamable HTTP is the other protocol that you'll see a lot in MCP. And that's like, a good example is the GitHub Copilot MCP server that's running in some box somewhere that you're hitting over the HTTP protocol. So in this case, I am specifying the MCP toolset here, and then I'm calling out to the Kubernetes MCP server. So what this allows me to do is it allows me to take an agent, excuse me, apologies. It allows me to take an agent, right, like Claude, and Claude is trained on, any LLM right now, right, like Gemini, GPT, Claude, whatever we're using. It's trained on a vast data set, okay? So that's why I can open up Claude and I can say, hey, what's going on with my Kubernetes environment? Here's the log or the event. And I can also ask it, hey, what's the best cooking recipe for chicken parm, right? So it has a vast amount of information. Now, if we want to get our agent to be a little bit more accurate, right, have the tools that it needs to answer specific questions for us, that's where MCP servers come in. So MCP servers are, essentially not trained, but created for a specific use case. In this case, I'm using the Kubernetes MCP server, and then I have a bunch of tools here. All right. Now, this MCP server actually has way more tools than this, but I can create a subset of those tools. For example, maybe you don't want every single person using an agent to have access to every single tool. From an hallucination standpoint, they actually say that if you're going, like above 18 to 20 tools within your agent, it starts to hallucinate more. So you always want to keep that list a little bit minimal, right?
I was also reading that there's a time period now, like agents were at like a 2-3 minute time period as it keeps on going. It's doing great.
Right.
But I think like 6 months ago, we were like in a 90 seconds. So now we're at 2 minutes. I feel like in 7 to 8 months, we're going to be at the 7 to 12 minute period where the agents can now just keep on going. But it's good to have like the instructions and specifying the tools, because you can't like you do everything you want. Like, okay, like I've had, I've downloaded and used MCP tools that I've investigated. I'm like, oh look, I've had like a Twitter MCP tool. I'm like, oh look, he's actually taking credentials inside his service. I'm like, hey, what do you do?
Right, exactly. Yeah, and we actually one of the pieces of the lab today that I'll dive into, I'll kind of show like how to only specify what tools you want to use from a security perspective. Because to your point, Sebastian, like that's why something like Agent Gateway is so important, which we're going to begin to talk about, because you don't know what the person is doing on the agent, right? You don't know what MCP server tools they have access to. So for all you know, somebody could open up an agent and they can say, hey, you have access to all these Kubernetes clusters, right? Go ahead and delete all of those.
Go ahead and spin up another agent and do something else malicious, like we saw the Claude Code, right? Recently, the attack, right?
Yeah, 100%. Yeah, like there's, out of the box, there's no security protocols. Like when you're talking agent to agent, when you're talking agent to LLM, when you're talking agent to MCP server, there's this line of communication, right? And again, that's where Agent Gateway comes into play. And that line of communication, like it's just open without something like Agent Gateway. And that's why, it's so important. And to that point, when I'm running an agent just like this, I would have some type of server, right? Because whoever's watching, right, you need to be able to, you need to be able to hit that agent, right? So how do you hit that agent? Well, for me, for example, like when I ran the Crew AI agent, like I'm just hitting this thing locally. But like out in the wild, if I want to get other people to be able to utilize this agent, I would need a server, right? So that's what this piece here is. This is the server for my agent. And it's specifying the agent skill. It's even specifying the agent card. And if you haven't heard of an agent card, it is what's exposed to let whoever knows using it the capabilities that it has, right? And then in this case, right, this is just an example. That's why I'm hitting localhost over 9999. And we can see that running right here. So I have the server running in the background. Okay, so we have all this. We have our agent. We have the server that's running our agent so people can actually hit it. Now, what do you do? So how do you secure the traffic? How do you implement authentication? How do you implement authorization? How do you implement rate limiting? How do you implement traces, logs, metrics? Everybody's probably seeing where I'm going at this point. To do that, you have to implement libraries like I'm doing here and like every other application stack. So you implement all these libraries and all these, third-party libraries, or you build stuff internally or whatever to do all this for you. And now you have to do this for each agent. So not only are you implementing these libraries and managing all this functionality yourself for one agent, you have to do it for 5 agents or 10 agents or 20 agents. That sounds pretty cumbersome to me. And I personally wouldn't want to be doing all that manually, right? And that's where something like Agent Gateway comes into play. So see a question that just came in here. Let me finish this thought really quick, and I'm going to go ahead and I'm going to answer this. So I have Agent Gateway running here. I'll just cancel out of this just so you can see how it works. So Agent Gateway, in this case, I'm just running the data plane, right? And I'm going to show you how it runs in Kubernetes as well. But this is just running the data plane here. So I'm pointing to my config.yaml, and this is my Agent Gateway config. So notice here, I have the port that it's listening on. I have the back end in this case. Remember, it is this server here, right? And then I'm specifying policies like cores, which don't do this in production, obviously. This is just for demo purposes. The methods, so get, post options, exposing the headers, and then I'm specifying the A2A protocol with a local rate limit, which I'm going to show you in a second. But before that, I just want to pop open the browser here, which I have one open to my left, so it's not playing nice. Okay, here it is. Okay, so this is the Agent Gateway portal here. Oh, what did I do? Oh, it would help if I ran Agent Gateway, right? All right, so let me go ahead and reopen that here. All right, we have our metrics, but let me just open up the playground, which we can find right here for the UI. All right. Okay, so this is the overview, and this is kind of what you see as soon as it gets kicked off. So you have your home button where you're seeing all the listeners, the routes, the bindings, etc. Here are our listeners that we set up. Again, this is just running a local host for the data plane. And then you have routes, your backend, and then all of your policies. So let me go ahead and stop right here. I'm going to answer this question that just came in. I know this is an example. You are filtering the tools with the previous knowledge of available tools to avoid a bunch of context information not needed in your use case. Am I right? Absolutely. So I'm going to go back here really quick just so I can showcase this. Right. So here are all the tools that I'm filtering. Essentially, if you take a look here, I'm almost saying like this is a read-only agent in a sense, right? Like it can list pods, it can get resources, list resources, events, namespaces, but it can't actually like go and create anything. And this is very, very important from an overall agent perspective as you're thinking about building out these agents in your environment. So for each agent that you build, you don't want it to have full pseudo access, right? Like you don't want it to have full root access. You don't want it to be able to do everything and anything. When you're thinking about agentic infrastructure, you want to split up what an agent can do based on what it needs to do. Sebastian, any thoughts there?
And just think about what workflows, like what is that agent, what workflow it's going to have, and giving it those tools to make sure it knows to use them for that workflow. So even before we start building an agent, hey, let's figure out what is the current workflow, what's the workflow of this agent going to be, and we'll give it those capabilities. So then we can limit it, secure it, and govern all that stuff. But it all comes down to AI workflows, right? And then we can specify those tools in there.
Yep, 1000%. Yeah, it really does come down to like, what do you want this thing to do? And speaking of what you want it to do, that's where various policies come into play. So if I click on this button here, notice how I already have A2A, right? Because I specified that in my config.yaml. And I also have local rate limiting. Okay, so if I click on this, we can get a visual of everything that I set up. Now, this is, of course, very strenuous here, right? I'm saying for every 100 seconds or every 1,000 seconds, only give me one token. That's, obviously insane, right? You wouldn't, well, maybe you would do it in production. Who knows if you want to irritate somebody. But in this case, I always bring this up from like a local rate limiting perspective or rate limiting in general perspective, because this is the conversation that I've been having a lot with customers, which is like, hey, I just got a $40,000 bill, right? These agents were running, they were hitting all these LLMs. How can I control spend a little bit? And even how can I look at metrics? How can I say, okay, there are these 3 gateways, or there are these 4 or these 5 gateways, they're hitting LLMs. How do I know how much all these are costing? How can I say, hey, you're only allowed 1,000 tokens for this specific, request? And that's where rate limiting comes into play. And it's a conversation that I'm constantly having. So I'm going to go ahead and showcase what this kind of looks like here. All right, so let me open this up. I'm going to open the terminal. And then I'm going to come over here, and I just have this, test curl here, right? I'm essentially just hitting localhost over 3000, which is, where the agent gateway data plane is running. I'm specifying the JSON RPC protocol, and the text is literally just test1, right? So I'm just like sending a message. So I'm going to hit that. Sometimes I gotta hit it twice. I think it's something that I have running locally here. So let me go ahead and hit that twice. Let's see if that works the second time. If not, I'll have to hit it a third time. So you can see the first time that it ran, right? It's just giving us some Kubernetes information. Okay. And one more time here. This should fail out.
And you're using Anthropics in the backend, or just the still DeepSeek again?
Yep, using Anthropic in the back end here. Nice. Yep. So you can see here when I hit it, because I'm using more than one token every 1,000 seconds, right? I'm getting this, hey, you got an issue here with your rate limiting. And it's funny, it actually says, oh, maybe you want to contact sales.
Look at that, eh? Surprised it doesn't have the phone number or the email there already. Exactly. Oh, it has the link right away. Yeah, that's awesome.
Yeah, but this is just one of like the many configurations that we can configure within our environment, right? Now, what I just showed here is specifically running Agent Gateway via a data plane. So I'm going to go ahead. I'm going to stop right here. I'm going to answer a question, and I'm also going to ask everybody a question, and hopefully I get a couple of answers here. So the question that I'm going to ask is, who here is running a Kubernetes environment, right? It could be 1 cluster, 5 clusters, 1,000 clusters, whatever, it doesn't matter. I have the chat open here. Just want to get a read of the room here. Can you use Agent Gateway to manage your MCP servers? And the answer, yep, Sebastian already answered that, but absolutely. So if I open up, and I'm going to show everybody how to do that.
Michael, how many Kubernetes clusters do you have in your home lab? I have 3. I think it's,
Yeah, so
or do you just spin them up and spin them down?
Yeah, I mean, I probably have like 20, but they're not all running at once. So like I have like a Raspberry Pi stack that isn't running at the moment. I have up there, you can see an Intel NUC that's running. And then I have an Intel NUC in my server closet / coat closet in my apartment here. And that I have an Intel NUC Extreme and a bunch of stuff. Yeah. All right. So let me pull this up really quick. and I want to showcase 1 second. Here's one of those answers to that question. Again, I'm going to show it in this lab here in a little bit. But to answer that question, yes, for like managing tools, there are some policies that we can implement that, again, I'll show you here. And then even from an authentication and authorization perspective. So you can set up authentication to your MCP server. You can set up authorization to your MCP server. So who can log in? And then once they're logged in, what can they actually do? So the full security suite of everything from limiting the rate to policies for what tools can be shown to an agent and to a person via the MCP server, all the authentication, all the authorization, you can manage it all with Agent Gateway.
And I think what's cool to note is, not giving your users the API keys to anything you want to manage, having this fronted with your SSO, Entra ID, let them authenticate through their processes and let the API keys all hide in the back end, so you don't have to share those. We just enable you in a group inside Entra ID and go. Use what you need to do.
Yep, exactly. Cool. All right. So for everybody that's running Kubernetes, I did want to show a demo of that as well. So the gist here is what I just showed, everything, you can run that in production without Kubernetes at all. So like if you're a bare metal shop, if you're an ECS shop, if you're running virtual machines, you're running on-prem, you're running in the cloud, whatever you're doing, you can implement Agent Gateway, right? Just as the data plane. Now, what if you're implementing it from a Kubernetes perspective? So what I'm going to do here is I'm going to show you a little bit of the infrastructure that I've already set up. So I am running on a GKE cluster. This will work if you're running on AKS, EKS, GKE, Kind, Minikube, K3S, wherever you're running, right? I'm just running it on GKE. Now I'm going to run kubectl get gateway, all namespaces, right? And we can see I have one gateway running and it's under the K gateway system, right? And then I can run kubectl get gateway class, namespace, K gateway system, right? And we can see K gateway and we can see agent gateway. So when you hear agent gateway, that is the gateway that was specifically built and designed for AI workloads, okay? So it's Rust-based, it's not Envoy-based, right? It's built specifically for stateful workloads. It's built specifically to look at the body of a request instead of the header, because with AI traffic, it's not stateless, it's stateful, right? So like, for example, I open up the Anthropic console and I ask a question, right? And then I get a response back. And then I ask another question, and I get a response back. That's what I think we're calling, right? Or at least what I'm calling context-aware networking, right? So like that traffic is going back and forth, and therefore it has to continue to be stateful. So Agent Gateway was built specifically for that use case. Now, when you're seeing K Gateway is another open source project, and that's for the control plane, right? So Agent Gateway is the data plane. K Gateway is the control plane. Sorry, I thought this cough was going to be gone after a couple of weeks.
It lingers, man. I've had it for like a month, and
me too. Literally, it's awful.
Yeah.
All right,
and
so
it's running through my kids too, which is always great.
yeah, I'm waiting for my son to get sick as well. Right around the holidays is always fun. So I have a gateway running, right? I have Agent Gateway. You can see here I have my gateway. This is what was deployed. I'm using the Agent Gateway class. Now, what I'm going to do is I'm going to set up a backend, and the backend is the destination that you want K Gateway to route to. So in this case, notice here, I'm using Claude 3.5, all right? And then I'm specifying my Anthropic secret. That's just my API key that I have a Kubernetes secret for, all right? So I'm going to grab this. I'm going to run the apply, all right? And then now what I can do is, well, we can just see the backend, make sure that it's there. Yep, it's accepted. We're good to go. Next, what I can do is I can set up this traffic policy. So this traffic policy is going to be very similar to what we were just showing around local rate limiting. Okay. So again, max tokens 1, fill every 100 seconds. And then in this case, I am pointing this to an HTTP route, right? So in the world of Kubernetes Gateway API, we have a gateway, which we define as our gateway. And then we have our route, right? Our HTTP route. And that's the route that we want our specific gateway to take, or rather, the route that we want to be able to hit our application, or in this case, our LLM, right? So I'm going to put together this policy here. Okay, and that was now created. And then I'm going to create my HTTP route. So in this case, I'm literally just going to, /Anthropic. And then this is one of the paths that I can take here. And then it's specifying our backend. Because like I said, that's what Gateway or KGateway knows what to route to. All right, so I'm going to apply this. All righty. So now what I'm going to do is I'm going to get the public IP address for the ALB of our gateway. I'm going to put that into an environment variable. There that is. And then I'm going to hit my LLM, right? So again, what am I doing here? I am routing to Anthropic, right? And then how am I doing that? I'm doing that via my backend here. I create the backend and it's going to Claude 3.5. Now, if I want to, I believe it's in here. It is, yeah. I can also specify the model in the request if I want. So let me go ahead and run this. All right, got some verbose output here just so we can see what's going on. And then we get that, right? Now let me hit that again. Boom, rejected. Now, if you don't have verbose output, you're going to see this and you're going to be like, what is going on here? But I have some verbose output so you can see I hit my rate limiting. Now, another thing that I can do as well is I can check the logs of the gateway. So if I do kubectl, get pods, namespace, kgateway system, right? Here's our data plane, right? Or our proxy. So I'm going to copy this. I'm going to paste it in here. I'm going to get the last 50 logs or lines rather, and then anything that has to do with error and Anthropic, right? And then we can see somewhere in here, we should be able to see the rate limit.
Just a question, I'll just jump in.
Oh, here we go.
Is rate limiting per user or for all users? And that really depends, right? You can rate limit in every instance, or a user, a team, right? So then you could even have a chargeback later on to those teams or that people. So
totally, 100%. Yep. So you can do it that way. You can also even go even more granular if you want to. And notice how my traffic policy, right? I'm targeting the route specifically. I can target the gateway if I want to. So like in this case, I'm setting up a traffic policy for this specific HTTP route. But if I wanted to, I could set up this rate limiting and this traffic policy for the entire gateway itself. All depends on how you want to do that. Yeah. Yeah. So there's a ton of granular options, right? But here's that log for the rate limiting piece. Okay.
and I posted in the chat just so people know. Inside the Git repo, there are examples on how to execute kind of rate limiting and run A2A stuff. So anybody can really just go ahead and deploy it and test it out if they want to ahead of time, which is good.
Yeah, 1000%. And then I even have a lab in here. If anybody wants, I'll go ahead and I'll put this in the chat. Where is this one? I have too much stuff in here. All right, let me pull this. Okay, I'm gonna put this in the chat as well. But this is if you want to be able to like manage cost from a usage perspective across multiple gateways. And you can see I have some screenshots in here, but this is for like 3 different gateways. I'm able to see token usage. I'm able to see hourly cost. I'm able to see total daily cost. This is a dashboard that I created, but you can get, everything within this code base here. And let's see if I talked enough. Nope, I got to talk for another minute and 50 seconds or so. So I'm going to spin up this lab here real quick. We're going to go through it. And really what this is going to do is this is going to help us tie everything together, right? So if we recap what we've done so far, we've seen how to create an agent, right, with ADK, the Agent Development Kit in Python. We saw how to set up rate limiting. We saw how to control that traffic via Agent Gateway. And then we saw how to do all of that within Kubernetes. So now I want to take it a step further, and I want to bring K-Agent in just for a second. K-Agent is a framework for managing all of your agents via Kubernetes. All right. So you're gonna see what this looks like in a second, but I can now, with K-Agent plus Agent Gateway, see all my agents, build my agents. I can build those declaratively via Kubernetes manifest, or there's a BYO option. So you can bring your own agent, whether it's Crew AI, whether it's ADK, like the one I just created, doesn't matter. You can implement all that into Kubernetes. You can scale that out just like any other pod, because the agents are literally running as pods in Kubernetes. And you can connect to MCP servers and manage, secure all of that traffic via Agent Gateway. Whew, all right, 27 more seconds. Sebastian, anything you want to add in there that I missed?
And not only are you deploying agents, and we're giving you a platform and framework to push those agents to your Kubernetes cluster. There's like the little nuances of like cool little features. I can actually just export everything to a YAML, update it to my GitHub, and have that whole pipeline process my agents too. So if you got developers, they're updating agents, they're building agents, create a PR, merge it, boom, let the whole system. And that's how we're going to see it in production, right? That's how we see things being deployed. And that's having this gives you that capability right out of the box, right? Which is great. Oh, your mic's off. I think you're on mute.
Oops, sorry about that. I
There
don't
you
know
go.
what happened.
No worries, man.
So this is Instruct that I'm using, and I don't know if anybody else has used Instruct, but it's a really, really cool platform. So like these labs were all built like literally in code, and then you can run them via Instruct. It's very interesting. So this is like a full demo environment, which is really great. So I'm going to sign in via Keycloak. So that's like the IDP provider specifically for this lab, but you can use Entra if you want to, if you're an Azure shop or whatever OIDC provider. So I'm just going to log in here, admin, password, very, very secure. I'm going to go ahead and I'm going to skip setup. But if you wanted to, you can go through the setup and then you can see things like, the agent that's running, the model that you're using, etc. So I'm going to click skip setup here. And then once we go to agents, we can see that there are a whole bunch of agents right out of the box for us. And if we do kubectl get pods namespace kagent, you can actually see those agents are literally running as pods. So just like you would manage any other workload in Kubernetes, you can do it the same way with your agents now, right? So I'm going to skip this part here, and I'm going to go straight to create an agent. So with K-Agent, what you can do is you can initialize a new agent. So in this case, it's utilizing the Agent Development Kit, right? It's specifying Python as the language of choice, giving it a name, specifying what LLM you want to use in the backend, or what model you want to use, and then what provider. So I'm going to copy this. I'm going to run it. All right. So now I'm going to open up. Where are we here? Here we go. We should see that load in just a second. There it is. Oh, right here, sorry. And then we can see our agent. So notice how it gives you a nice scaffolding here. It gives you a Docker file, gives you the kagent.yaml, where we're going to see in a second to put our MCP servers in. And then here's our agent. So just like I was showing you in VS Code before, this is just another agent that's built via ADK. All right, so now what I'm going to do is I'm going to cd into demo agents. And then I'm going to run kagent build, and that's essentially building our container image for the agent. This should actually be pretty quick. I think this is running kind in the background, and it's actually pretty fast. Yeah. So the goal here is we're taking our ADK agent, right? And remember the whole BYO, bring your own agent thing. What you can do is you can now containerize this thing and then you can run it within KAgent, just like all those other agents. That way you can manage them, like I was saying before, like any other pod in your environment. So you got to connect a secret to it. You got to connect a config map to it. Whatever you have to do, you're able to do that. I'm just looking here. I don't think I have missed any questions. No, I think I'm all good. All right, cool. So that's built. I can do a Docker image ls, right? And we can see that container image here, right? So now I'm going to run my agent. And this is really cool in my opinion because I'm using KAgent to run my agent locally to test it out. But if we come here and I do a refresh, notice it's not here yet, right? Like it's not running in KAgent. So if we're thinking about dev, UAT, or staging production, right? We have built our agent. We're testing it in dev or in UAT. And once we know that it's working as expected, we can then publish it to KAgent and then we can see some tracing and such.
And even before that, like you published it to, there's a local registry for a Docker running on this instance.
Right.
So you published it to the local Docker. So if you have your own Docker hub, like I've already published like 16 agents to my Docker hub in the last week. All right. You can put them all there and build them however you need to.
Exactly. Yeah.
This part I love that when you did KAgent run. I love being able to test it.
Yeah. And that's exactly what we're doing here. I'm just asking the agent what it can do. And I think that this is super crucial to make sure that your agent is working as expected, right? Like any good engineering workflow, you have to have a solid QA practice in there. And there's no reason why, because these are just commands, right? So like, there's no reason that you can't go and put this in your CI workflow. Like, why not take the same exact process, put it in your CI workflow, and do all of your agent testing that way? So that you can get very, very granular with this level of mindset, right? Just like every other engineering practice that you have, you can implement the same mindset in your AI workloads. All right, so we can see here, it can roll dice, cool. So now what we're gonna do is we're gonna use the KAgent CLI to add an MCP server. So in this case, I'm just doing the server everything, and then I'm specifying the command. It's an npm package, so we're going to use the npx command, and then we're specifying for the arguments what MCP server it is. All right. Okay, cool. So now if we go back to our scaffolding here, and I'm going to do a refresh. Let's see if it popped up yet. Yep. All right, cool. Here it is. So within our kagent.yaml, we can see our MCP server here, right? So now, if I go back to the terminal, I'm going to do a build just because I added the MCP server, right? So I got to rebuild my image, which should be pretty quick.
Yeah, Mark, you can add and configure remote MCP servers to it also too. Just to answer the question.
Yeah, so if you're talking about remote MCP servers like streamable HTTP, yeah, you can add those in as well. Like this one's a standard input output STDIO, and it just caches the package essentially because it's either an npm package or a PyPy package. But yeah, you can hit streamable HTTP MCP servers as well. All right, cool. So now I'm going to run KAgent run again. And I'm going to ask it, what can you do? So before we got the output, that was like, I can roll dice. Now let's see what it says. Non-deterministic workloads, you never know what it's actually going to say. That's why every time I go into a demo, I'm like, come on. Okay, cool. So now you can see because of the server everything MCP server, it can do a lot of different things, right? That's
We
why
have to let it think sometimes, man. You can't,
that's it.
12 seconds, I think it took. We have to let it
Yeah.
think sometimes.
Not too bad. Yeah.
Can't be mean to the AI, right? We have to be nice.
No,
He
always
knows
say
it's
please and thank you.
Yeah.
Yep. Regardless of how expensive it is, when the AI overlords take over, they'll remember that I always said please
That's
and
it.
thank you.
That's it. I don't think the memory is that long yet in them, but I hope they do. That's why you got to continuously do it,
Exactly. Okay. So
So-
the next piece here. Oh, sorry. Go ahead, Sebastian.
No, Mark, he just asked, are each of those 12 actions separate agents? I think those are separate tools.
Separate
inside
tools.
separate tools inside the MCP server.
Exactly. Yep. Yeah. So a big thing to remember with MCP servers, right? And Mark, I'll ask you, like, what's your background? Are you more like on the infrastructure side, or are you more on like the software engineering side? That way, I can answer that question a little bit better. And I know like there are a couple of different, folks in here in terms of like leadership and, infrastructure and software, et cetera. Wasted tokens, true. Yeah. But as long as you're not the one paying for it. Okay, so enterprise architecture and development. All right, so what I want to do is I'm going to break down like what that whole MCP server thing is, right? So you saw all those tools in there. An MCP server like is literally a package, right? It's like a third-party library module, whatever you want to call it, and within there you have different functions, right? And those functions can perform different actions. And that's what your MCP server tools are, literally functions inside of some third-party library or module. So when you see that full list, or even when I was showing this piece here, where's my button? I can't get over. Hold on a sec. There it is. Okay. So this list here, I'm just specifying what functions, or in this case, tools, right? Because that's the name for MCP servers. I'm specifying what that can do here. So that was the output you were seeing before. Okay, cool. So the next piece here, and I know we're almost at time, so I'm not going to go through the entire thing, Sebastian. I think there was something you wanted to show as well. But the next thing that you want to do is you want to make sure that you can run your workloads in a declarative fashion, right? So like maybe you're using a GitOps controller or something like that. So this piece here, I can take my OpenAI key and then I can put it in a local file called .env.production. Yes, you can go and you can store that in a GitHub secret if you wanted to, or HashiCorp Vault or something like that. However you want to do it, and then pull it down as a Kubernetes secret, right? And then once you do the deployments, right, I'm going to show two more things here, which is the access policy and then reviewing the traces. So we can come in here, right? We can go to one of our agents and then we can say, what's the status of my cluster, right? And then we'll go ahead and we'll ask it that, right? And then we can see some output here. So this is my cluster currently. If I go back to the UI and I go to tracing, right? We can see here, this should pop up in a second. There it is. Okay. So we can see the trace tree, the output, and then this is one of my favorite pieces here, which is the actual execution flow, right? So you see how it keeps bouncing back and forth? I'm going to play that again. That's not me clicking anything. It's bouncing back and forth. That's why I think context-aware networking is so important, because remember, there's traffic going back and forth constantly, which is why stateful is so important, which is why Agent Gateway exists, because that is by definition a stateful-based gateway for AI workloads. All right, now I'll show one more thing here, and then I'll hand it over to Sebastian. A couple of people were asking, right? And I was talking about, hey, what about my MCP server traffic? How am I going to secure it, et cetera? With Agent Gateway, oh, do I not have that here? Okay, here it is. So you see this traffic policy? This is how we can combine K-Agent and Agent Gateway. So we set up a traffic policy here, and then we can specify what traffic can be called from the agent. And this is essentially happening with this backend. So you see here that we have the backend and it's an MCP backend. If I open up the base here, remember how we were calling out to the LLM before, Claude, as the MCP backend? Instead, I'm specifying my backend as the MCP server, right? So in this case, the backend is MCP. I'm going through standard routing, creating a gateway, right? The only thing is that I'm saying I want my backend to be an MCP server. That way, I can manage that traffic via traffic policy. So I can specify, hey, you only have access to these tools, right? As in the agent. So anytime that anybody uses the agent, they can specify the backend as an MCP server. They can specify a traffic policy, and then they can lock down what tools are actually available for that agent. And when you're doing it via agent gateway and you're doing it via traffic policy like this, nobody can do a workaround, right? 'Cause that's a question that I get asked a lot as well. Hey, well, this agent doesn't have access to, these tools in the MCP server, but they can just go and curl it, right? Or they can use another agent. You can't, because with agent gateway, you're specifying this traffic policy here. All right. So I'm going to stop sharing. I'm going to hand it over to Sebastian.
Yeah, awesome. I'll quickly share another demo, another lab environment of what I have. I think everybody can see this fairly well. But really, I've set up a demo where I do have Agent Gateway running, where I have things that I'm going to test based off privacy, PI, rate limiting, or even budget or cost tracking, because I think that's important, especially as we kind of move more and more into enterprises building out agents or kind of developing workflows itself. Let me just run this demo. And like I mentioned, 3 parts. We're talking about the security, privacy, so preventing data leakage, P2 or PI, or P2, redaction and data security, right? We did little cost controls or rate limiting, or even creating budgets for the team itself, and then providing reliability. We saw outages happen, right? We saw Cloudflare went down, right? Someone made a boo-boo. And then I actually saw a funny meme. Someone updated a database and they're like, oh no, I did something wrong. And then they go, hey, log into ChatGPT to see what we did wrong. But then ChatGPT is down because it uses Cloudflare, right? So we want to be able to have reliable and flexible, like multi-provider strategies itself in here. So what I'm going to kind of show is really a couple use cases. One is data privacy, and this kind of flows through where I'm actually connecting to, or I'm asking the AI through agent proxy, questions, what's 2 + 2, right? And it's giving me, hey, there is no API code release because I'm hiding it, right? I'm successfully hiding the code, so I can query the actual my agent gateway. I can query my LLM without providing an API key, right? Giving us this capability of API will never be exposed to the client, centralized credential management, easy key rotations without client updates, and audit trails, right, from all API usages. So we store everything, everything's kind of audited. Then from a next use case itself is what happens if we want to actually do some redactions or data security. We don't want people to accidentally type in their credit cards, the social security numbers in it. So we want to provide guardrails into the system that we can say, hey, if it's a credit card, if it's a social security number, I want you to redact it. I want you to maybe answer the question, but just redact it automatically to help the user not be able to do it. And then we can see those responses are being kind of redacted inside the queries, or prompting credit card information. If I query, hey, please charge my credit card for some subscription, I'm going to redact that through the gateway. So I have those kind of capabilities inside the platform to do that. Or having even multiple issues, having your credit card or your social security, right? It doesn't matter, but we have those capabilities to redact specific things, right? Because we want to be GDPR, HIPAA, SOC compliance, especially through data protection inside the platform. Then really the next one thing is kind of rate limiting. How do we set up rate limiting? Maybe we have specific budgets that we do 10 or 9 or 12 requests per second per team per user. And this is what I'm doing. I'm actually sending real requests out to through Anthropic, through XAI, and through OpenAI, and it's giving me different controls. Right, I hit a rate limit, so it switched to a different provider to give me that access, so I can kind of have this automatic intervention, or well, really no manual intervention, to be able to route users based on real time and based on whatever limit we have set. Maybe certain ones are more higher. Or if
Yeah,
we're doing, sorry, go ahead, Mike. But yeah.
Oh no, I was going to say the question came in. Does this have the ability to flat out block the request if something is being sent by the user? And the answer is yes. So I don't know what Sebastian has built into this, but from an agent gateway perspective, you can implement something called policy guards, which essentially said, like, let's say I say to the agent, hey, delete all of my Kubernetes clusters throughout all my organization. You can set up a policy guard that says, if the prompt says delete, don't allow it to occur.
That's 100%. And that's what I was using prompt guards inside. You could actually even, and I've set this up, if you have a third party, what's it called? IDP, we can proxy that connection, send it to the IDP, send it back, clean it out too. So that's always capable of doing it itself, which is super powerful. And another example demo for here is kind of enforcing budgets and speed limits. So spending limits. If we have a limit per person, per team, we can actually get these outputs, get these results, and have this. Maybe we have a chargeback model. I spoke to a customer. They're building out lots of agents. They want to charge back the usage of those agents, those LLMs, the providers they're using to different teams. So we have the capability of understanding who and what teams made the request, and then giving a chargeback model to those users itself. So then we could track costs on those devices itself.
All right, guys, we're pretty much up against time. Just want to say this has been an excellent presentation with a very engaged audience. So there's a lot of information that you guys just went through. So I would like each of you, if you can, in like a 60-second statement to, what would be a key takeaway for folks to, go back to their jobs with, and how can they get in touch with you after this webinar if they want to follow up with questions or more personalized information. So let's start with Michael.
Yeah. So in terms of like where you should go from here, I would say continue reading, continue understanding that everything in this space is changing at the moment. The protocol that's designated for today may not be for tomorrow. So just always keep that in mind.
Great. And Sebastian?
Yeah. Use AI to learn AI, to be honest. It is fascinating. Don't get discouraged if Claude doesn't answer it. Ask ChatGPT. Maybe they'll help you out itself. But for a product perspective, if you check out, agentgateway.dev, you can get started. I posted in the chat some examples of code, and it's super simple to deploy and test in your environment, be it in your Kubernetes environment or just on your laptop. Very easy itself. So if you're looking to kind of connect or, hit us up, Michael and I are pretty active on LinkedIn itself. We have, if you go to agentgateway.dev, there's a Discord channel too that we have for all our products. That a lot of our community members are having conversations. And we also have weekly office hours for Agent Gateway, where we allow community individuals that are working on new projects, new engagements, or just playing around with the product to ask questions or demo what they're working on. So
that's fantastic. All right. Michael Levin, Principal Engineer, Sebastian Magnac, Principal Solutions Architect at Solo.io. Thanks for being here, fellas. Really appreciate it.
Thanks, everybody.
Awesome. Pleasure.
Okay. I'd like to thank Solo.io for sponsoring today's webinar. Great job there. And of course, thanks to all of our attendees for showing up and joining us live. We appreciate your questions and your attendance. So thanks so much for being here. Until next time, I'm Dave Rubenstein, Editor-in-Chief of SD Times. So long for now.